we want to have a look at complex numbers. So we'll start from the beginning and see, what the purpose of them are. If you remember from primary school, you would have your real number line and it would continue on in both directions, the minus way and the plus way. And the purpose of, on your real number line is that we would have every solution to any equation that I would want or any question that I would have. So perhaps what number plus 3 gives me 1? Well, what number when I go up 3 gives me 1 and we have minus 2? Or 100 divided by 7. Again, it might be a decimal, but I could put it on my number line. My solutions to all these equations or questions are on my real number line. However, if I asked you to get the square root of minus 7, I can't get a solution to that is on my real number line. And this is where complex numbers comes in. I have to, or I want to be able to continue on with questions, even if I can't maybe fully get a real number answer. That doesn't mean I can't continue with a question and get an answer. So what happens is we introduce the concept that the square root of minus 1 we're going to call I. And then everything complex numbers we're going to base on that. What does that mean for my number line? Well, it means that we're going to have to introduce another dimension to the number line. And if you see here, we have our real axis here. And now we have our complex number, or imaginary axis here. And this argand diagram allows me to plot, any point. So here's I. So if I asked you what's the square root of minus 1, you would be able to tell me the answer is I. And now, even though it's not an answer on my real number line, it is a solution that I can find on my argand diagram or my real and imaginary axis. So keeping this in mind, we are then going to try and work out questions that we may not have been able to work out before. So if we look at maybe questions to do with complex roots. Like if I asked you to solve this equation, x squared minus 6x plus 13, where x is the missing number. Now it doesn't matter if they had said z squared plus 6z or minus 6z plus 13 equals 0. I'd still be solving for z in that situation. So what do I normally do? I'm going to try and work with, the factors of 13 that add to give me 6, so they don't exist. So I'm going to use my minus b formula. So we have minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. That gives me 6 plus or minus the square root of minus 16 all over 2. And up until, coming across the concept of complex numbers and the square root of minus 1 is I would be stuck here. But now I'm going to look at the square root of minus 16. And the square root of minus 16, or if we look at even minus 16 is the same as 16 times minus 1. I can get the square root of 16 and the square root of minus 1. Square root of 16 is 4 and the square root of minus 1 I'm now considering to be I all over 2. And then we have 6 plus 4i all over 2 and 6 minus 4i all over 2, which I can then simplify down to be 3 plus 2i, 3 minus 2i. So a question I would not have been able to complete before, I can now complete thanks to this concept here that the square root of minus 1 I'm going to replace with I. It's possible for me to plot these numbers now on my argand diagram. So if we had 3 plus 2i, we could go to 3 on the here and 2i here, and then 3 minus 2i could go here. So it allows me to plot these numbers on my number line.